So welcome back. In this video, we're going to do some more debunking. And this one is going to be debunking of some of the many myths surrounding solar energy. Now, I know solar energy is gets to be a very emotional issue, and people get very tied up in their beliefs. And it becomes more about what people want to believe than what the facts dictate. So, honestly, if you feel like you are really invested in the solar energy, and you would get very upset if somebody might challenge your beliefs with some facts, you probably don't want to watch this video because I'm going to be talking about some data surrounding solar energy that might deflate some of your beliefs. On the other hand, if you're interested in looking at some data surrounding solar energy and find out what the real numbers are, this can be very beneficial, I hope. So what we're going to do is we're going to look at a few solar energy myths, and these are the ones we're going to start with. There's 5 of them, and these are ones that I hear very often, and they are, for the most part, pretty much nonsense. So the first one is the most common one, and it is the furthest from the truth. It is that solar energy is free energy. And we're going to talk about that. It is absolutely nonsense. It is, in some ways, the most expensive energy. And people love to believe things, and this is one of the things that they desperately want to believe, but it is totally untrue, and we'll show you that with some data. The next thing is equally funny to me, and there seems to be a belief that solar energy and wind energy, and by the way, a lot of this applies to wind also. We're just going to focus on solar now. There's a belief that solar energy is like this awesome new technology that was just invented, I don't know, by millennials in the last 5 or 10 years. And again, that is utter nonsense. And we're going to talk about some of the history of solar and where it stands now relative to where it was many years ago. Now, the third one is not necessarily a myth. It's more of a conclusion that you have to accept if you're going to believe a lot of this solar mythology, and that is that the sun is perfect and everywhere. It's kind of like believing that solar energy is free. You also have to believe that the sun is perfect and everywhere and it's always available. Again, utter nonsense, and we're going to talk about some of that. Batteries, when people get pressed into accepting or hearing about the unreliability of solar energy, they naturally jump to, oh, well, just use batteries and that will solve any of the problems. Again, pretty much nonsense. Yes, I mean, they have a benefit, but we're going to talk about some of the negative parts of batteries. And then they also, if nothing else works, they'll say, well, it's good for charging my stuff, using portable solar cells to charge my phone and stuff. Again, there's other options that make this kind of comical. So now, again, I am not against solar energy. I think it's got some great uses, but they're very niche uses. I mean, if you have a recreational vehicle or you're out in the woods, again, that doesn't reflect a large portion of the population, but there are some people who benefit from it. Again, it's very expensive for them, but there are some good things about it. I'm just trying to give some data regarding the majority of people, how it affects them. So the first thing I want to talk about is the myth that solar is free energy. Okay, utter nonsense. And the first thing you might want to consider is this. Down here you can see a power plant that your utility probably uses something like this, and it's belching out smoke. But what it does is it burns either oil or coal or natural gas. And those are resources from the earth that you take directly from the earth. You basically dig a hole and bring them up, and you process them and use them to burn and to heat up steam to run generators to give you electricity. But basically those also are free energy, right? I mean, they're coming from the earth. So why is that any different from solar? I mean, you dig a hole, you pull it out, and it becomes free energy. They're free for the taking, just like solar and wind. it's all free. Isn't that right? I mean, aren't they all free? Well, absolutely not. That's totally wrong. You have to pay for all forms of energy. Now, why do you have to pay for them? Well, you need to pay to get them to where you need them. You know, you got the sunlight outside, but that doesn't bring it into your house and power your refrigerator. You need to gather them, you know, whether it's solar or wind or oil or coal or gas, you need to gather them and convert them to the form you need them, right? Again, sunlight doesn't power your refrigerator. You need to convert that light into electricity of the right form that can be used by your refrigerator or your microwave or whatever else you're using. So none of it is free. In fact, it can be very, very, very expensive. With solar, you need panels to gather the sun and controllers and converters to convert it into electricity and wires to bring it into your house or wherever you're bringing it to. Same with oil, coal, and gas. You need to extract it from the earth and refine it and convert it and deliver it to your house. And all of this can be incredibly expensive. And the same thing goes for wind. So, you know, all of this requires big money. It's not free. None of it's free. It comes from the earth. It comes from the natural resources, but none of it is free. It can be very expensive. And again, solar can be one of the most expensive depending on how you're using it. So let me give you an example. You can go on YouTube now, today, and you can find many videos by people who have installed, as you can see up here in the top right, solar panels on their roof to power their house and maybe to sell some electricity back to the utility. And they have kept track over months or years to see exactly what it has cost them and whether it has been worth it, okay? And let me just give you one example. And this example is fairly typical of what you will see in terms of actual numbers. Now, this is from somebody in California, sunny Southern California, where there's a lot of sunlight, so you expect there to be a lot of benefit from solar energy. And he installed, as I recall, something like 18 panels, solar panels on his roof. And he also installed a fairly expensive battery for when the sun wasn't shining to store some energy. And the total cost of that system was somewhere around, now get this, it was between $20,000 and $30,000. And that's not unusual. If you're going to put in a sizable solar system on your house and install a battery, it can be upwards of $20,000 or $30,000. Now, if you don't think that's expensive, then that's fine. But for the vast majority of people, that's a lot of money to come up with to pay for something like this, all right? So $20,000 to $30,000. Now, in your case, it might be less. It might be $5,000 or $10,000 if you don't install a battery, and you know, depending on the size. But this is kind of typical for some people to install. Now, he checked to see how long it would, based on how much money he's saving by not paying the utility company, instead getting it from the sunlight. You know, how long would it take to repay this $20,000 or $30,000 by the cost savings of using sun instead of utility power? And he came up to something around 10 to 15 years, okay? And that's not uncommon. You might get down to 5 or 10 years, depending, again, it varies a lot, but you might get more. This is in California where it's very sunny, so if you're in an area that doesn't get a lot of sun, you're not going to benefit a lot from the solar panels, and it may take you 10, 15, 20 years to pay back this, you know, $10,000 or $20,000 or $30,000 you spend to put this in. So, again, when you've got your utility company with these big belching power plants, you don't have to come up with $20,000 or $30,000 for your electricity. You pay as you go, right? You give them $50 or $100 or $200 a month for the electricity usage, and that's it. You go on every month. You don't have to come up with this. So for some people, this is an extremely expensive way to get free energy. And you can see it's not free. It's very, very expensive. And at some point, you're going to hopefully pay back this initial investment, and it could take many, many years. So let's look at a specific example. You can go out today and do this, and let's look at how long it might take you to pay back. So this is an example. You can go to a place called Harbor Freight, which has stores. I think you can go online. And they've got some really nice stuff, basically tools, mostly tools for people who need tools. And they've got a section on solar equipment that you can buy for your home. And this is a really nice example of a fairly low-priced set of solar panels and a battery to go with it. And you can see here, it's got 4 solar panels that are kind of foldable, as I understand. It's got a bunch of equipment to go with it. And it's a 100-watt solar panel kit. And you can see it's got a lot of very good positive reactions, 700 reactions up to almost 5 stars. And this thing costs about $190, okay, for 100 watts solar panel kit. Now, if you know anything about what different equipment in your house takes for power, 100 watts used to be a light bulb was 100 watts. Now they're down to 20 or 40 watts. But, you know, that's kind of the range. You can power a light bulb or a couple light bulbs if you have 100 watts of solar panels. Now, what you often want to do is you want to add a battery. So, you know, you charge the battery with the sunlight. So you have a battery it's like with your cell phone. You've got a battery in your cell phone. So when it's not charging, it will give you electricity. So here we've got a 12 volt, 35 amp hour acid battery lead acid battery for $70. Okay. And again, a lot of positive feedback on this. So this 12 volts and 35 amp hours, if you multiply 12 times 35, you'll get 420 watt hours of DC power, okay? So 420 watts for an hour, or 210 watts for 2 hours, or 105 watts for 4 hours, or however you want to use it. But you've got stored in here 420 watt hours of DC power. Now what that means is you have put these solar panels out in the sun, and they deliver at very best, the maximum output of these solar panels with bright sun directly overhead on these panels, 100 watts coming out of the panels going into the battery, and you will need at least 4 or 5 hours of 100 watts to charge a 420 watt hour battery, okay? So that's how you would have to work it. You'd have to put these outside. You get a lot of sun, basically an ideal sun for 4 or 5 hours to charge this up, and you will get 420 watt hours of DC power. So if you buy this, and you can do this today, you can try it out. It will cost you, let's say, about $270. You add these two up, and you might have to pay shipping or taxes or whatever, but let's just say it's about $270. Now, the alternative is to use the power company, and the cost of 420 watt hours is going to be about 5.5 cents for 420 watt hours. And what we said is this is going to take maybe 5 hours, 4 or 5 hours of direct sunlight to charge this. So you can pretty much assume that you will only get like 1 day's worth of sun to charge this up. So because the sun's going to go down, and it's, 4 or 5 hours is a lot to expect for bright sunlight during the day. So it's going to cost you 5.5 cents for 420 watt hours. Now, you can check that. The average, if you go on the internet, the average residential utility customer pays about 13 cents for 1,000 watts for an hour. So for 420, that's only 42% of that. So 42% of 13 cents is 5.5 cents. So you can assume that if you use this and it's working at maximum, you will save 5.5 cents per day that you would otherwise have to pay to the utility company, okay? So, again, that requires 4 or 5 hours of perfect sunlight to fully charge this battery. So, okay? Now, the important thing is I paid $270 for all of this equipment. At what point do I get a payback? In other words, at 5.5 cents a day, if I'm using it, if I'm charging this battery every day for 4 or 5 hours and using that 420 watt hours later on after it's all charged, and 5.5 cents a day I'm saving, how much do I have to use this? How many days do I have to use this to finally pay off the $270? Well, divide 270 by $0.55 per day, $0.055 per day, that comes out to 5,000 days, okay? 5,000 days is about 13 years, all right? So now we're saying that in order to pay off your $270, it's going to take you 13 years of perfect sunlight, 4 to 5 hours per day, and you're going to use that 420 watts after this after this battery is charged, okay? So even at this low level, you know, you're spending only less than $300, 13 years to pay this back because, you know, you're not getting much out of the solar panel, all right? So there's also restrictions and cautions with that. You know, it's not for certain it's going to be 13 years. It could be much longer, or it could be less, but it depends on your situation. So again, you need to only charge the battery in full perfect sunlight 4 or 5 hours every day and not use the solar for anything else, okay? You then need to use the entire battery during the night, because if you're not using the solar, you're not benefiting from it. So you got to use it. You also need to have or buy special 12-volt DC powered lights, refrigerator, water heater, or whatever, okay? Most of your equipment, most of your appliances are, in the US at least, 120 volts alternating current. This provides direct current. This battery provides direct current. So you need to have special DC powered equipment or appliances, or you need to spend even more money and get what's called an inverter to make it into alternating current so you can operate your AC powered appliances, okay? Now again, with all of this expenditure, you're only limited to 420 watt hours of energy per day. That's not a whole lot. I mean, you know, your microwave, when you run your microwave for an hour, that's 1,000 watt hours, okay? So it's really not a whole lot. It's, you know, a few light bulbs and you're not really getting much. Now the other caution and restriction is you're going to be carrying around a 24-pound battery and some large panels and the equipment. So this is 24 pounds, this battery, and you got these panels and you got the equipment you're going to carry around. You know, not ideal, okay? And then the next thing is you got to realize that if you completely charge and discharge this battery every day, that can reduce the battery life. They recommend that you don't charge and discharge it completely, that you only do maybe 50% to prolong the battery life. So again, there's a lot of difficulties here, and you need to also have perfect sunlight, which we're going to see a little bit later. Chances are you're not going to have perfect sunlight. So now your 13 years is going to get even longer, okay? So again, it's not ideal by any means. Now, myth number 2 is that solar is this awesome new technology, all right? Utter nonsense, okay? For those of us who have been around for some years, back in 1982, that's almost 40 years ago. We're in 2020. That's almost 40 years ago. And at that time, the first solar power plant, called the Arco Solar 1 power plant, was put in service in California. And Arco is the Atlantic Richfield Oil Company. Yes, that's right. An oil company built the first solar power plant in California in the desert in 1982, and it used big panels, something like this, and the output was 1 megawatt, and that can feed something like 500 or 1,000 homes, depending, but a whole lot of people can benefit from that, and that was back in 1982. Okay, so this is not new technology. This is very, very old. In fact, people were designing these panels back in the 60s and 70s. All right, so nothing new about this. All right, this has been around for many, many years. And if you're wondering why, if it's so awesome, why doesn't everybody have solar panels on their roof? Well, we're going to find out that it's not, and as we've already found out in the first couple of slides, it's kind of expensive and it's not really that great. All right, so don't be surprised if it's not taking the world by storm. There's some downsides to it. So one thing that's interesting about solar cells is a discussion of the efficiencies. Now, what is the efficiency of a solar cell? Well, over here I've got a sunlight coming down on a solar cell, okay? And the job of the solar cell is to take the sunlight and convert it into electricity so that you can use it, all right? Now, efficiency is an indication of how much or how efficient this solar cell is at converting this sunlight into electricity, all right? So looking at the historical efficiency is a really good way of figuring out, has this technology progressed in the last 40 years, or is it pretty much flattened out, and is it really nothing's new here and we're just doing the same thing we've done for 40 years? Well, this is a wonderful chart developed by the National Renewable Energy Laboratory, or NREL, and it shows the best research cell efficiencies, and they go back to 1975, okay? They start in 1975 and go up to here we are in 2020. And if you look at this in general, you can see there's many years of, a lot of these are just flat, okay? Very flat efficiencies. And keep in mind, these are the very best in the business. Some of these are used by NASA. They're very expensive, very relatively high efficiencies. And what I've done here in this red area is shown where the residential, what's available to residential customers at reasonable prices, what the efficiencies are. And it's generally been fairly flat since the 1980s. And it's generally in the 16 or less than 16 to a little above 20% efficiency. So in other words, the sunlight coming from the sun on this panel, only 15 or 20% of that will get converted into electricity. All right. So let's zoom in and look at the ARCO solar cell efficiencies back in 1982-83. And you can see here's ARCO, and you can see their solar cell efficiencies were in the 16 to 20% efficient range. And that's when they were doing the first solar cells. And as you can see, you can go online right now. This is, go into Amazon, and here's a typical solar cell from a company called Renogy. And if you go down into the spec sheet, you will find the electrical data. The cell efficiency is 21%, okay? And this is a very common solar cell that you can buy online. So again, we're in the 16 to 20% range, and it's been that way for 40 years, okay? Now again, you can spend a ton of money and get some more high efficiency cells, but keep in mind that those are extremely expensive and not what most people do. So, the next myth I want to talk about is the apparent presumption or belief that the sun is perfect and everywhere, okay? That everything is ideal and we live in this, utopia of fuzzy pink unicorns where everything is awesome and perfect and sun is free and perfect and everywhere. In fact, that's not the case. In fact, it's very much the opposite. So, how do we determine what the ideal case is? Well, scientists have shown that the sunlight, when it gets through even a very clear atmosphere like you see here, there's basically no clouds in the sky, the ideal amount of solar energy or solar radiation hitting the ground is ideally, at a maximum, something like 1,000 watts of solar energy in a 3 foot by 3 foot square area. Actually, they usually measure in square meters, which is about 3 feet by 3 feet. But so in a 3 by 3 foot by 3 foot area, the ideal amount of solar radiation that gets through onto the Earth's surface is about 1,000 watts. Okay, and if you know about electricity, you know that, oh, that's the same as the power in the electrical circuit. So you might think, oh, well, I've got 1,000 watts hitting the surface, so I can put a solar panel there and I can get 1,000 watts of electricity and run my microwave, which requires about 1,000 watts, or run my window air conditioner, which requires about 1,000 watts. Well, no, that's not how it works. That is an absolutely ideal condition, and we're going to see in a bit that it's not this ideal situation. So what I want to do is look at the actual stuff compared to what the ideal situation is. And we said before, here's a graph based on hour of the day and the solar watts per square meter. And I'm showing a graph of the absolutely ideal situation where you can see here the peak is 1,000 watts per square meter. But since the sun is down here at midnight, there's no sun, which means there's no solar radiation hitting the Earth. And around 5 o'clock, maybe the sun's starting to come up and you're getting some solar radiation. And as the day goes on, you're getting more and more sun. And if it's directly overhead around noontime, you're getting your 1,000 watts ideally. And then as the day goes on, it gets less and less and goes down and the sun sets and you get nothing. So that is the absolutely ideal situation, right? So you can see you get a lot of sun only a few hours of the day. The rest of the time it's coming up, going down, or else it's midnight. Now, here is a graph of actual measured solar radiation at a location, and this one is in Southern California in the US, and it's in Santa Monica, sunny Southern California, Santa Monica, California. And this is, I just picked a random day, and you can see a couple things here. First of all, the maximum on a sunny day goes up to only around 700 watts per square meter, not the 1,000 watts per square meter, all right? And you can also see that it's fairly uniform like this ideal curve, which implies there's no cloud cover, all right? So as it comes up, there's a little dip here that might be a small cloud going over, and here another dip, and maybe a cloud here. But in general, this is a very sunny day, but you can see it only goes up to about 700 watts per square meter, all right? And this is in sunny Southern California. Now, let's look on the other coast. Let's look this is outside New York City, where you can see the actuals, and this is going to be on obviously a cloudy day, where you got a lot of clouds coming over. You can see it starts, the sun comes out and then a cloud comes over. Sun comes out, cloud comes over. And here it gets very cloudy around 11 a.m. Sun comes out again, cloud comes over. And then after lunch you get the most, and then it comes another cloud and that kind of thing. So the maximum you get that day is 400 watts per square meter. Not even close to the 1,000 ideal, but only 400 watts. Now, you can get this data yourself. This is easy to come by. If you don't believe it, check the data at your location or any location you want. And the way you do it is this. Go to your favorite weather forecasting website, and all of the data that the forecasting website is based on generally comes from what are called personal weather stations. So people, volunteers out there in the US, I'm talking about, buy these personal weather stations that measure temperature and how much rainfall, and in some cases they measure solar radiation hitting the Earth. And you can go on those websites and you can find a personal weather station that has that, and they maintain the data. They keep a database of that data So you can look at what happened yesterday or last week or last month at many, many locations around the US and get these graphs, and they'll give you the graphs directly. So that's what I did. I checked a couple locations, got the graphs, and saw what the actual numbers are, okay? So it's not ideal, all right? In fact, the ideal case is extremely rare. It's more likely you're going to get something much less, and in an area where you get less sunlight and you get more clouds because of the weather, you get storms and stuff, you're going to be down very, very low, okay? So that tells you that the sun falling on a solar panel can vary widely, okay? And it can be all over the place depending on cloud cover and the time of day. And it's very difficult to predict. And you can see it's kind of unreliable because you don't know. I mean, a cloud could come over and suddenly the solar radiation drops on your solar panel, okay? So you can see that we've got a lot of variation in solar radiation, but that's not the whole story. There's more to it, right? So here is another thing from the National Renewable Energy Laboratories showing the average solar radiation for different parts of the US. And you can see down in the Southwest, you get a lot of solar radiation, and up in the Northeast and the North, you get much less. There's more cloud cover. So it depends a lot on where you are in the US, and so it varies a lot. So it doesn't, good sun is not for everybody. It's depends on where you are located. So let's now talk about the solar panels themselves. We've decided that the solar radiation coming down at any point on the ground can vary widely, but let's look at the panels themselves. Now this is a 100-watt solar panel, and it's rated for a maximum power at STC of 100 watts. Now what does that mean? Well, if you look down at the specs, it says all specifications and data described in this data sheet are tested under standard test conditions, STC, where the irradiance, or the solar radiation hitting the Earth, is assumed to be 1,000 watts per square meter, okay? Now, we said before that is very unlikely depending on where you are, what's the time of the day, what's the weather, and it might be down as low as, 400 watts or 200 watts or 100 watts per square meter, okay? So this 100 watts is at an ideal 1,000 watts per square meter that you might not get. So if you're at, say, only 400 watts per square meter, you might only get 40 watts coming out of your solar cell, right? If you're 100 watts per meter, you'll get 10 watts coming out of your solar cell, okay? So again, it varies a lot, and you can't assume you're going to get any usable amount of power out of your solar cell. So again, we've got 100 watts maximum, a 12-volt solar panel. The cost might be $100 to $200. And again, the cell efficiency is 20%. And if you look at the dimensions, it's about 40 by 20 or 0.5 square meters. So the reason why it's, if you have 1,000 watts per square meter hitting the surface, you only get 100 out, is because two big things. You've only got about 20% efficiency, and you don't have, if you multiply this out, it's only half a square meter. So it's not, you're saying 1,000 watts per square meter. Well, it's only half of that. So if you multiply this all out, if you get 400 watts per square meter, the panel would provide only 40 watts. So that's where that comes from. It depends on the efficiency and the actual size of the solar panel, right? If you're looking at per square meter, if it's not 1 square meter, then it's you have to allow for the different size, okay? So again, 1,000 watts coming in means only 100 watts coming out, and you're rarely going to get 1,000 watts. It'd probably be a lot less. Okay, so in the next video, we're going to finish up on some of these myths and talking about the really big myth that people seem to kind of ignore for some reason, but it's a really big deal. And that is the question of what do you do when the sun goes down, right? So if you have solar panels on your house and you're supplying your electricity mostly from your solar panels, what do you do at night when everybody comes home from work and from school and everybody's cooking food and you're watching TV and you're doing all your stuff? What do you do when the sun goes down and your solar panels don't put any electricity out? You have to rely on the utility company, which means the utility company has to have a power plant or a bunch of power plants that don't use the sun, and they have to have these reliable power plants that operate on coal or oil or gas to provide you power when your solar panels aren't providing you power. So now you have two power plants. You got yours plus the utility. And you can see how this gets very, very expensive, and people don't really think about that, right? You've got 2 times the cost. So again, we'll talk about that in the next video, and we'll talk about some other things such as batteries and some of the other myths. So join us in the next video. Otherwise, take care and have a really good day. Thanks.